Tobias Bausch, CMO and CTO at AP&S International, discusses the company's batch processing, single wafer processing and support equipment technologies, with the emphasis very much on continuous innovation to deliver cost-saving, operationally optimized and sustainable customer solutions. The conversation also covers some of the current industry challenges, including ongoing supply chain issues and skills shortages, as well as the opportunities offered by new and emerging markets.
Okay, so we're going to have a chat about AP&S today, and I guess the obvious place to start would be if you can give me a little bit of background on the company, you know, the history and some of the sort of key milestones today.
Yeah, great, for sure. So thanks for the possibility to have this interview. The company itself, AP&S, was starting in 2003, but the history starts in 1995. So the current shareholder, Horst Hall, starts the business in 1995. Then in the time from 2001 to 2003, we was part of the SEZ group, and we was called as SEZ Germany. The batch part during this time when SEZ Austria had a single wafer portfolio. And 2003, Alexandra and Horst, the current shareholders of the company, do a management buyout and found the company AP&S. So therefore, I tried to explain the history is much longer than 2003. So this year we have the 20 years anniversary. So in July, we celebrate this with the company employees and the partners. And yes, over the last 20 years, we developed several tool platforms, mainly in the wet process sector. So all our machines used in the wet departments on our customers. And during this time, for sure, we have several milestones. We investigate in an in-house lab where we can run demonstrations for customers. The demonstration lab starting in 2012. And as I said, over this time, we have a lot of redesigns or redevelopments of machines, new developments of existing machines or new machines. So 20 years are a long time to do a lot of developments for the industry.
Yeah, and it would be good then to move on to the technology. You obviously referred to it there in your answer, but the actual technology solutions you provide. So if you can perhaps run us through, I think the batch processing solutions are one of your main sort of strengths. So yeah, if you can talk us through those.
Yeah, existing. So we have the existing 3 platforms. It's the batch, the single wafer, and the production supporting equipment, or facility logistics, we call it. And the batch is this one where we're growing up. So since 2003, we're starting with the batch tools. We have there several platforms, semi-automated and fully automated platforms. We try with the smallest platform. It's a 2-tank solution, where customers can have etching and the cleaning application in one equipment. And mostly this tool will be used or was used from customers which coming from manual operations, where the operator handle the carrier, the wafers manually, and they want to go to a kindly automated production. So this customer use this equipment. And the next platform is a tool which called multi or giga step. It's a bridge tool. It was developed in the 2009, 2010 years, where we have the possibility to run in these platforms very easily 6 and 8 inch in a bridge combination without any kind of modification between the wafer sizes. So at the moment, this will be very requested related to the silicon carbide issues and the gallium nitride requests. And this tool platform itself is very modular and flexible. So the customers could also decide by today to go with a tool configuration for a cleaning application. And anyhow, in the future, when their needs changing, the products changing or whatever, we could reconfigure easily by adapting the modules or insert or disassemble modules, or insert new models, the tool configuration. So that's one of the key benefits of this platform. And then we have a high throughput platform. We call it A series, and new development. It's called Nexa Step. Is up to 12,000 wafers per day, mostly for cleaning applications. We run in this case with 100 wafer batch per load. And therefore we have this year, within the year, by end of the year, let's say, we will have the market launch of the Nexa step, which is a new development, but I think we discuss later on about develop it more in detail. And last but not least is a very special tool. It's ELS metallization equipment for underbump metallization. We call it Vulcanio. We start this development in 2009. And I think by today we are at the most of the customers in Europe, the process of record for this ELS metallization, where we can have a nickel palladium gold metallization on copper or aluminum pads. And yeah, this tool platform was one of the biggest success stories in the history of AP&S. Our targets at the end is to have a clear enlargement of the bath lifetime, because the ELS chemistries are quite expensive compared to standard chemicals in the semiconductor industry. And the specialty on this equipment also is the very good metal layer uniformity in the batch process, so that the customer can run on a higher throughput base on a better total cost of ownership, this metallization process.
Okay, that's nice to hear. And then we can perhaps go on to the single wafer processing technology. If you can just outline what it is you do in that area.
Yeah, so the single wafer equipment we developed in the early 2010, 2011 years. And as I said, we also decide very fast to go with the single wafer in a demo application to show the customers the possibilities to run demonstrations. And in the meantime, we run not only demonstrations, we also run R&D activities in the lab. The tool itself is a very small equipment, let's say small in view of footprint. We can start with one chamber. It's called a single chamber. We could adapt it with a robotic module to have automated loading of the wafers or the masks, and up to a double chamber. So the biggest enlargement of the tool configurations are 2 chambers, a double chamber solution. But in the chambers itself, we are not limited. So we could run up to 12-inch on the wafer base and up to 9-inch on the mask side. And during the development of the machine, we decide to give the machine the name of the processes wherefore we have designed it. So we have, for example, a spin mask, which is in the name clearly, that's the equipment for the mask cleaning. A spin lift-off, it was designed for metal lift-off applications, or a spin RCA, spin scrubber for typical cleaning applications, or spin metal or spin etch for etching applications. And each of them have specialties and different features related to the processes. For example, the spin metal we developed for a metal etch application and endpoint detection system, which is included inside of the process chamber. And therefore we had, in this case, one example we had developed with a customer and realized etching for 3 metal layers. So they have a metal layer of silver, nickel, and titanium. And with this endpoint detection, we could realize a very fast very fast process steps. We can reduce clearly the undercut and the overetch, and especially we can compensate any kind of chemical concentrations, temperature variations in the chemistries, over the time of the chemistry usage, dilution or degradations. So all these things was compensated, even if we take a look on the etching endpoint. And this was for example, one of the benefits we could include in these single wafer chambers. As I said, there are a various of features related to each dedicated process step.
Yeah, and it sounds like you described there that you collaborate quite closely with customers. So I guess you produce what we call a standard range of equipment solutions, but then you will work with individual customers to customize them for their specific needs. Is that right?
Yeah. So especially single wafer or even on the batch, I forgot previously to mention, so we also include in this demo center 4 years ago a batch demonstration equipment. And this is what we see. So as I said, we do a lot of R&D activities with the customers. So they came to us, they have a dedicated problem. Sometimes they could not solve it in their own facility. related to contamination issues because they are not allowed to run different tests on production equipment, or at the moment for sure they are all fully loaded, so they doesn't have the time to do a lot of R&D activities in their own production lines. And then they came to us with the waivers, with the issues, and we do together the R&D activities in our lab, find the best setup, or even find a new setup with new features like ozone, like megasonic supporting, whatever. And then at the next step, we try to implement it on the existing machine of us, customer sites, or if for sure needed, we will develop a new machine for the customer itself. And we build it. And yeah, during the manufacturing phase, we try and we go ahead in the lab to bring the process as close as possible to a production running parameter setup.
Okay, and you mentioned as well at the start that you make a range of support equipment. So again, it would be good to understand, support equipment that covers a multitude of sins. So what does that actually mean?
Yeah, so the supporting equipment, or we change it to the new definition in the near future, fab logistic equipment, is the third pillar of our product portfolio. In this case, it includes also cleaning equipment, but especially for carrier boxes, Smith and FOUPs in this case, or parts or tube cleaning equipments for parts made of quartz parts, and chemical delivery systems. So I think this is the basics every fabrication needed to run the production. And especially on the carrier box or Smith or FOUP cleaning, we see in the last years a very increasing demand for sure. The ramping of every customer is ongoing, and if you have more wafers in the facility, or you're producing more wafers, you need more boxes, and these boxes has to be cleaned, and therefore it's one-to-one clear that the customers need more cleaning equipment. But also we could generate and provide to the customers a clear benefits if they go back to in-house cleaning. So in the industry, in the last 10 to 15 years, several of the customers doesn't want or doesn't do this in-house. So they gave out their boxes, their FOUPs, their Smith to cleaning centers externally. But at the moment, we see the benefits to bring it back in the own facility. So you have, in this case, clearly faster reaction time. You have a higher flexibility when you have to clean boxes or FOUPs immediately. You could reduce the logistic costs. Yeah, you doesn't have to send it out to an external provider, get it back, and so on. You lower the number of parts which you have to have in the loop for the cleaning. And at the end, for sure, reduction of the cleaning costs, something which can be calculated and visualized. And I think what will be more important in the next years, the carbon footprint could be much better, because you doesn't have to send parts on a longer logistic way to the external partner. As I said, you can reduce the logistic costs, but you also can improve your carbon footprint.
Okay, and in terms of the applications, I mean, I think you've referenced the main ones. So you're focused on a number of application areas. I'm cleaning and etching would be the main ones. Are there others as well? What are the focuses exactly?
Yeah, so these two are, I think, the typical ones which we are coming from, and which the company history was grounded on, was typically cleaning machines in the front end production for pre-diffusion cleans or post-CMP cleans, whatever, and etching equipment for the typical front end steps for oxide etch, nitride etch, silicon etch, and so on. So this is the basis where we found our tool base, where we found our process know-how, and so on. And over the last year are several things coming add-on. So special solvent applications was very important over the last years. And I think AP&S was one of a few worldwide which include solvent applications in machines where we have a tool configuration in parallel, also with acid steps or cleaning steps. So especially these things, solvents, and so on. You have to know what you have to do related to the security issues and so on. But that's one of the the additional focuses and applications we do. The metal etch I explained previously on the single wafer. In the meantime, where we had developed this single wafer metal etch with the endpoint, we also go ahead and do this development on a batch platform. It's on our multi-step and gigastep tool platform to upgrade or enlarge the throughput capability. Yeah, on the batch tool, everybody is clear. On the batch tool, you will have a higher throughput application possibility compared to a single wafer. Both equipments has their benefits and pros and cons. But especially the metal etch was growing over the last year. And yeah, as I said previously, the ELS metallization, this is one of the most popular applications we focus on at the moment. This is also coming for sure from the mega trends we have at the moment with the decarbonization, green energy, electrical cars, loading stations, and so on. At the end, everybody needs power devices. On the power devices, you need a good metal stacks for the UBM, for the underbump metallization. And we see also here that these metal layers where we can realize with the ELS process steps are very good in the terms of quality, temperature, and so on for these new technologies. Yeah.
Okay, I mean, as you've been answering, you've alluded to a lot of the technology solutions and clearly some innovations along the way. But is it fair for me to ask, are you able to sort of summarize some of the recent innovations, or at least highlight some of the most important ones as far as you're concerned, what you've been developing recently?
No, I think I can summarize, let's say, 3 of the main innovations we do at the moment, or we have done in the last 2 years. We had a very huge in-house software department. So the company accounts at the moment 250 people, but the in-house software group is, compared to this number, a huge group, and we do this with a clear strategy to have it in our own hand, to have the software in their own hand, the development of the software in their own hand, because we also see that software features, interfaces to customer interfaces, handling solutions, and so on would be the key in the future. So we speak about AI, we speak about predictive maintenance, and so on. All these things are related at the end to a software feature, so that the tool itself, control itself, measure itself, diagnostics itself, to see if a part, even a pump, a heater, whatever, coming in the next time to a failure, and so on. All these things are related in the software, in the software code, and therefore we do there, let's say, a lot of investigations and innovations, and also what is clearly focused, but that's nothing new, that's in the industry since quite a while, the request to increase and optimize the throughput of the machines. Yeah, so you can even lower the costs in the production if you can optimize the throughput, can reduce process times, can save chemistry costs, or in this case also it would be in terms of the green footprint of the company, a good feature to save chemistry volumes and costs. So this is something, as I said, we take account in the software. The second is, as I said previously, the Nexa step, where we in the development phase, actually we built a machine currently. This will be a machine especially designed also for a high throughput 8-inch application. We will have inside of the machine a unit to stock up to 44 transport carrier or boxes, and it allow us to have a very flexible handling of it, yeah, in terms of recipe control and throughput control, and it allow the customer also to stock carrier boxes and so on inside the equipment, and can bring it to the equipment in a time when the time is available, yeah, and we use it, we stock it, and we gave it back to the fab when the production or the recipe is finished. And this is a tool, as I said, with additional also process features. We're reducing some process activities, like, for only one example, reduce the rinsing time, yeah, to save time and to save also money, and to save at the end the eye water, which also be good for the whole environment on the customer side. And the third is our Clean Surf. It's the equipment we developed over the last 2 years. It's a new cleaning equipment for fab logistics and especially for cleaning of the FOUP. The equipment is able to run 12 FOUPs per run, and we see that we have a time or a recipe reduction from approximately 10 minutes to benchmark equipment. So we also could increase here the process sequence and enlarge the throughput at the end. And this equipment is developed with the implementation of automated loading system. So especially on high automated 12-inch fabrications, we see that the demand to load the machine not by an operator, so to load the machine by an overhead transport system, also coming in the parts cleaning area. So, and this is something we focus on, and the development of this fully automated loading system is ongoing. And I think we came out with the market launch in the next, 1.5 years.
Okay, and you're also presumably alongside what you're doing sort of within your own organization, you're also working with a range of partners or customers on again specific sort of solutions for some of them into the future. Is that right?
Yeah. So I think the next years we at the moment see that the new materials, silicon carbide, gallium nitride, which quite impressive ramping at the moment, will take a lot of count of innovations of developments. So we had mostly every second R&D activity we do in the lab is related to such of these materials. Also, again, on the single wafer, we have different applications for new processes where we have new metals, where we have new resists and so on. So this will be there some activities. And for sure, on the ELS part, as I said, at the moment we're running there the metal stacks for nickel, palladium, and gold. But I'd be sure that in the future here also the next metals will become. Here the industry is quite linked to the chemical supplier. So we at the end only, let's say, only equipment supplier. But we here in a quite close contact to the chemistry industry, which are providing these chemicals, and at the end to the end customer, which need the new metal stacks. And I'm sure that this will be one of the next R&D activities in the next 2 or 3 years, where we do research with partners.
Okay, and I mean, a lot of your success is clearly based on the people and the skills you have within your organization. And I know you pride yourselves on your recruitment and skills development. It's very important to the company. So particularly, I guess, at the moment where, all sectors are maybe struggling a bit, but the technology sector, that we constantly hear of, skills shortages. So what sort of initiatives do you have in terms of both identifying suitable people to join yourselves, and also then once they're in the company, how do you help them to develop?
Yeah. So in the south of Germany, when we are located close to the Switzer border and to the Lake Constance, we have for the employees a quite good situation. We have a lot of strong companies, and all of these are looking for high qualified and good people. So for the company itself, as you said, is quite difficult to find the right people. We could say that we in the last 3 years during the pandemic situation on the R&D sector, we find very good people. So I think there was the situation that a lot of people from the universities, which are finished with their study and so on, looking for new jobs, and not everybody was in the time at beginning of 2020, 2021, and so on this moment. On the way to hire new people. So we decide early in this phase that we use this situation, and we get a lot of students with a very good success on their bachelor or master thesis. We get them in the company. So on the R&D sector, we have a better situation compared to the manufacturing area. On the manufacturing area, it's quite difficult to find the people which produce the machines, which working in this sector. And therefore, I think it would be the most challenge over the next years to find there the right people and people with the good skills and the right skills. We also try to hire people which coming from industries closer to the semiconductor industry, to the machine manufacturing industry. We have a lot of machine manufacturers around of us, which are in the metal sector. And for us, our machines, most of our machines are made of plastics related to the chemistries and so on. And that's the way we go ahead. Yeah, and for sure the internal studies and trainees is one of the biggest things we do. So we have in several departments trainees, and most of them, or let's say all of them, will be after their trainee time and after their study time part of the AP&S team. So we do this very carefully, and I think we have at the end, if they are finished with their study, we have several options. So they could start in an R&D area, or in sales or marketing, whatever, or if they want, and if the technician features are quite good, they also can start especially in the manufacturing sector.
Okay, you referenced the pandemic. It's still sort of vaguely in the background for a lot of us. So do you think, sort of more generally now, do you think the industry has more or less recovered from the impact of the pandemic? And if so, or whatever current state is, what sort of opportunities and are there any sort of challenges still off the back of it? And are there any opportunities on the, on the plus side coming out of, or, as we get back to some kind of, I guess it's the new normal, isn't it? Everyone's calling it, but yeah, where we are now.
Yeah, that's a difficult question, because I think over the last 3 years, nobody was able to say what happens next. So I think at the beginning, 2020, everybody was afraid, and nobody know what coming soon. And then I think especially the semiconductor industry was at end of 2020 very fast in a way, and since this time everybody is growing and ramping up. Yeah. If it's going back to normal, I don't know. At the moment, we see that the parts we need out of our own industry, PLC controller, motor controller, whatever, still have a lead time of 50 weeks, so approximately 1 year, which is one of the onlyest parts where the lead time not going back. So on other parts, we see the lead time was also in the past close to 52 weeks, and they're going back to 44, 42. So there we see a reduction, but especially on the electronic parts, we doesn't see a clear reduction. So therefore, I don't know if we are on a normal level, or if we are back on a normal level. For sure, we see that the demand of semiconductor also related to a higher demand of equipments, which was for us measurable in the order entry we have over the last 2 or 3 years. And for sure also this was related to several mega trends we have, the 5G, the e-mobility, decarbonization trends, and so on. If this continues over the next 4 or 5 years, I hope so. And if you take a look on all this market research, it seems to be that it's going on this way. Especially the power industry, power semiconductor will grow more than others. But what is the new normal? I don't know. I think is at the moment, especially industries and ecosystems like Europe, like Germany, like other European countries, see that the globalization which we have prior the pandemic was very good and great, and it is not a problem to have a supply chain which is around the world. So I think in the semiconductor industry, the supply chains was typically around the world, and it is clear for everybody. And then we have this pandemic situation and this crisis, and then everybody see, okay, the supply chain was cut on different points. And at the moment, for sure, for the European people, it's interesting and great to see that we have a lot of new projects, a lot of new growing fabrications, even Intel coming to Germany, Infineon decide to expand, TSMC, if stopped or not, was in discussion to have a new fabrication in Germany or in Europe. And this, I think it's great, but I don't know if this would be the first step to have a from the decentralization to the external production, coming back to a internal production on each continent. Or so I think this will be, if we are back to a new normal, I don't know. I think we will have also a lot of movement in the market, and let's see what happens in the next 3 years. So we had now 3 years pandemic time, and I think it takes minimum the same time to see what is the new normal.
Yeah, and I guess to the sort of situation you described, you add in the sort of geopolitics, which is having an impact on supply chain. And also, I guess I was going to ask about sustainability, so perhaps I can throw that in there as well, because I mean, logically, sustainability requires potentially shorter supply chains, just because it, as you mentioned earlier, with outsourcing certain activities, if you've got a transport cost that you can reduce just by bringing the supply chain closer to your so are you able, I know it's a complicated situation, but are you able to just sort of analyze what sustainability means for the industry, and or particularly the supply chain, and anything around the sort of geopolitics as well?
I think that geopolitics, I'm not a politician, so the geopolitics situation is quite difficult. And 2 years ago, nobody believed that we will have a war in Europe. Now we have it. So what happens in the next 3 years? I think it's quite difficult to answer on this. It is important in the semi industry to have a strong network, and also to know and have scenarios, backfall scenarios, what happens when such situations came, or what happens not when such situations doesn't came. On the sustainability view, for sure, the resources we have are not endless. So if we take care about the materials, if we take care about the raw materials, or especially on the employees and the technologies, we have to find ways to improve what we do. So to handle the resources we have, even if we speak about water, which I believe will be in the next years one of the most important resources around the world, not even on the areas where we know that water is a high good. So I think it will be difficult in the next years around the world to have it in the right volume and in the right quality. And our industry is one of the industries which need a lot of them. And I think this should be the target, to focus on activities to save these resources, raw materials, water, whatever. And this will be also the success in the future. These companies which find a way to handle these resources on a good way, which are going on a sustainability strategy, would be successful.
And I mean, just as a matter of interest, are your customers, if you like, more interested? Are you noticing that your customers are more interested in sustainability? When they're talking to you, do they ask about your sort of sustainability initiatives and your supply chain? Is that becoming increasingly important, or is that not yet sort of manifesting itself in your customer relationships?
No, it's going more important. So we're getting these questions more and more. We are part of several sustainability projects. Even if you have at the moment, or we have customers which have fabrications which are 20, 25 years old, and for sure they will run these fabs for more than the next 20 or 25 years. They have clearly and clear communicated sustainability strategies. And for us, it's clear as a supplier of this industry to go ahead in these strategies, to find ideas and ways to coming close to the targets which the customers have, and find our own way, our own ideas to fulfill this sustainability request from the customer sides.
Okay, I mean, we've covered a lot of ground, and I'm really grateful for the time you've given me. I don't know if there's anything else you'd like to say, any final thoughts, or if we're done. So yeah, over to you if you've got any final thoughts.
So it was a lot of questions. Thanks for this, and I hope I could give a good impression of what is AP&S doing and what is AP&S standing for. I'm in the industry since 2006, so it's quite a long time. Even I'm not so old, so I'm at the end of 30, close to 40. So, but I see a lot. I like the industry quite much. So there is a lot of innovations inside. The people you met in the industry, and as I said, it's a global industry. You every time have contact with people in Asia, with people in the US, even in Europe. It every time is nice. So the people are every time focused on the new trends, on the mega trends, I call it previously, which are in our age and our environment is needed. And this is makes fun. So even if everybody is doing his job and his business, but I think it is a great situation if you have a great time when you're doing your job, your business, and you have nice people around of you. And therefore, I could say, I think, especially in the semiconductor industry, it's a small family. If you know the people and you're working many years in the industry, you know a lot of them, mostly all of them, and it's a great industry, and I hope it continues, and we're growing more in the next years altogether.
Okay, well, I say it's been fantastic to talk to you. So, Tobias, I really appreciate your time. Thank you very much indeed. Thank you.
Phil, thank you very much, and have a nice day.